10 common solar inverter faults and how to troubleshoot them. Have you ever installed a solar inverter that suddenly stopped working, started beeping, displayed a fault code, or refused to power your loads? Don't panic. An inverter fault does not always mean the inverter is damaged. Sometimes, the real problem could be the battery, PV array, wiring, protection device, temperature, communication system, or even an incorrect setting. In this video, we'll look at 10 common solar inverter faults and the practical steps you can take to troubleshoot them. Whether you're a solar installer, technician, homeowner, electrical engineer, or simply working with inverter systems, this guide will help you approach inverter faults systematically. Let's get started. 1. Low battery voltage. One of the most common inverter problems is low battery voltage. When the battery voltage drops below the inverter's acceptable operating range, the inverter may shut down, produce an alarm, or disconnect the loads. What should you check? First, measure the battery voltage using a reliable multimeter. Then check the battery state of charge, battery terminals, cables, fuses, breakers, and battery connections. For lithium batteries, also check the BMS status, because the BMS may have disconnected the battery due to low voltage, overcurrent, temperature, or another protection condition. Do not immediately blame the inverter. The battery system may actually be the source of the problem. 2. Overload fault. The second common fault is overload. This happens when the connected load exceeds the inverter's rated capacity. For example, connecting heavy loads such as air conditioners, pumps, electric heaters, refrigerators, or multiple appliances at the same time can cause the inverter to trip. Troubleshooting. Check the inverter's output power rating and compare it with the actual connected load. If possible, switch off some loads and restart the inverter. Also remember that some appliances have very high starting currents. A motor may have a relatively small running power but require significantly more power during startup. So, always consider both running power and starting or surge power. 3. Over temperature fault. Another common problem is inverter overheating. Solar inverters generate heat during operation, especially when operating under high loads. If the inverter temperature becomes too high, its protection system may reduce output or shut it down. Check. Is the inverter installed in a properly ventilated location? Are the cooling fans working? Are the air vents blocked by dust? Is the inverter exposed directly to excessive heat or sunlight? Clean the ventilation openings and make sure there is adequate clearance around the inverter. Never ignore repeated overheating alarms. Continuous operation at excessive temperature can shorten the life of electronic components. 4. PV overvoltage. Number 4 is PV overvoltage. This is particularly important for solar installers. If the voltage coming from the PV array exceeds the inverter's maximum PV input voltage, the inverter can generate a PV overvoltage fault and, in severe cases, components can be damaged. Troubleshooting. Measure the PV string voltage. Check the number of panels connected in series. Then compare the calculated maximum string voltage with the inverter's maximum allowable PV input voltage. And don't calculate using only the panel's normal operating voltage. You must consider the open circuit voltage and the effect of low temperature on PV voltage. Incorrect PV string design is one fault that should never be taken lightly. 5. PV low voltage or no PV input. The opposite problem is low or zero PV input voltage. The inverter may display a PV low voltage alarm or simply refuse to start solar charging. What should you check? Start from the PV modules and work toward the inverter. Check the DC isolator, fuses, connectors, cable continuity, string voltage, polarity, and combiner box. A loose MC4 connection, damaged cable, blown fuse, open isolator, or incorrectly connected string can prevent the inverter from receiving the expected PV voltage. Use a multimeter or appropriate PV testing equipment and follow proper DC safety procedures. 6. Grid ORAC input fault. For hybrid and grid-connected systems, another common fault is AC grid failure or abnormal grid voltage. The inverter may report grid undervoltage, overvoltage, frequency abnormality, or grid loss. Troubleshooting. Measure the AC voltage at the inverter input. Check the AC breaker, isolator, cables, terminals, phase sequence where applicable, and incoming supply. Also check whether the grid frequency is within the inverter's permitted range. If the supply is unstable, the inverter may correctly disconnect itself to protect the system. So, don't automatically conclude that the inverter is faulty. 7. DC bus overvoltage or undervoltage. Another fault you may encounter is DC bus overvoltage or undervoltage. The DC bus is an important internal section of the inverter where DC power is managed before being converted into AC. This type of fault can be caused by abnormal DC input conditions, battery problems, internal component failures, or control system issues. Troubleshooting. Check the battery voltage and PV input first. Look for abnormal voltage fluctuations. Check the inverter's fault history and manufacturer's diagnostic information. If external inputs are normal but the DC bus fault continues, the problem may be internal and should be handled by a qualified technician or the manufacturer's service team. Avoid opening the inverter unnecessarily, especially when dangerous DC voltages may still be present. 8. Communication or BMS fault. For lithium battery systems, communication faults between the inverter and BMS are becoming increasingly common. The inverter may show a battery communication error even though the battery itself appears normal. Check. Is the communication cable correctly connected? Is the correct communication protocol selected? Are the CAN or 485 rupees connections correctly terminated? Is the correct battery profile selected in the inverter? Also check whether the battery and inverter models are actually compatible. A battery can have sufficient voltage and still refuse to operate correctly because the inverter and BMS are not communicating properly. 9. Ground fault or insulation fault. Number 9 is a ground or insulation fault. This can occur when a DC conductor becomes damaged and comes into contact with earth or another conductive part. Moisture, damaged cables, poor installation, rodents, mechanical damage, or defective PV modules can contribute to insulation problems. Troubleshooting. Inspect the DC cables, connectors, junction boxes, and PV modules. Check for physical damage and moisture. Where appropriate, perform insulation resistance testing using suitable equipment and procedures. Do not simply bypass the protection system to make the inverter run. The protection is there for a reason. 10. Inverter not starting. Finally, we have one of the most frustrating complaints. The inverter is not starting. Before declaring the inverter faulty, check the basics. Is the battery voltage within the required range? Is the DC breaker on? Is the PV voltage available? Is the AC supply available where required? Are there active fault codes? Is the emergency stop or shutdown function activated? Are the inverter settings correct? And is the battery BMS allowing discharge? A systematic check of these conditions can often identify the problem without replacing the inverter. The golden rule of troubleshooting. Here's one important principle every technician should remember. Don't troubleshoot by guessing, troubleshoot by measuring. When an inverter develops a fault, don't immediately replace the inverter. Start with the simplest possibilities. Check the fault code. Check the battery. Check the PV input. Check the AC supply. Check the cables and protection devices. Then investigate communication and internal components. Always follow the manufacturer's manual and safety procedures. Remember that solar PV and battery systems can contain dangerous DC and AC voltages, even when the system appears to be switched off. So, the next time your solar inverter displays a fault, don't panic and don't guess. Read the fault, measure the system, identify the root cause, and then take corrective action. If you found this video useful, kindly like, subscribe and press the notification button for more contents awareness. This is Gab Tech Insights, your reliable channel for practical information on solar energy, power systems, electrical engineering, troubleshooting, and field maintenance. At Gab Tech Insights, we don't just talk technology, we help you understand it, troubleshoot it, and apply it. Remember to leave your comments and I'll see you in the next video.